Okay, so this video will show you how to calculate average and standard deviation using Excel. So let's say I have an experiment where I'm measuring the concentration of the products in molar that is created, and I did 5 trials, 1, 2, 3, 4, 5, from 3 different temperature, right? 30 degree, 40 degree, 50 degrees. And these are my results. So to find average using Excel is quite simple. Just say equal average, and then I will highlight the number of the average that I want. So essentially what I'm finding is the average of all these 5 trials for the condition of 30 degrees Celsius that I want. That'll give me this. I can put the arrow, the cross thing in the bottom, and drag it across, and then I will have this. Now, one common mistake that student made is that they just leave the average however decimal there it is. Well, that's not correct. If your data, let's see, this data, it has no decimal, then your average has to follow the same rule. It has to have the same number of decimal, which is none. Now if your data, on the other hand, you measure it up to, say, 2 decimal, one decimal, then your average will follow the same suit. Your average will then also be, oops, sorry, that was more. Your average will also be 1 decimal. Yeah? Okay. Now, how many decimals should my number has? Well, that's depend on the accuracy of your instrument, really. Okay. Well, what about standard deviation? How do you find that? Oh, that's also fairly simple. You just hit equal ST standard dev, that's standard deviation, and then I will highlight the same number that I want. Try 1 to trial 5. These are my numbers. Enter, then it will give me standard deviation. Have the little cross across, so then it will copy across to the other shell. Once again, my standard deviation should be the same as the uncertainty that I got. So sorry, I probably should modify this. Concentration of product, and let's say my uncertainty here is plus or minus 0.1 molar. So I know my uncertainty is this much, therefore all my decimal can be up to one decimal, and the standard deviation will also be that way. Okay? Now what does this mean? So let's say, why do I find average of things? Now let's say if I didn't find these averages, what I would do would be highlight the whole thing, and then maybe adding like a column graph here, and I would have a graph looking like this. Well, number one, it is incredibly cumbersome, and number two, it doesn't tell me what I wanted to see, which is how are the temperature affecting my enzyme concentration. So if you get something that looking like this, it is completely useless. Okay, so that's why we had to find the average. So when you find the average, and I'm not going to what it does, I'm just going to demonstrate a little bit, is that let's say here's I have temperature. Let's say I'm looking at 30 degrees Celsius, and over here I have the concentration of enzyme plus. Just bring that straight over here. So at 30, I have my first try at 39, so maybe it's somewhere around here. 47, that's up here. 43, that's over here. 44, a little bit higher than that. 45, a little bit higher than that. So when I have all my try lining up in that same line, you could see that if you find an average, that will give me this, the middle points, and that would make it a lot easier to understand. So average is like the middle point within all your different value. That's the average. Okay, what about this? That's the average. What about the standard deviation? Well, standard deviation tells you how spread out your data is. So standard deviation of 3 means that your data is going from the average up 3 unit and down 3 unit. So you're going to have something that look like this, that go up 3 and down 3, and then at this little bar that will tell you what does that mean.